Hi everybody, I just want to make a quick video kind of talking through some of the important ideas in our second Excel lab. This lab has 4 different tabs. The first one that's currently open is the instructions. The instructions are pretty brief here, but one thing I wanted to bring to your attention is this 4th thing. It says cells like this one with the tiny red flag in the upper right corner, maybe you can kind of see that flag up there, have hints in them. So if you hover over the cell, you don't have to click anything, the little hint will pop up. It's just an extra feature called a note in Excel, and it doesn't show up like when you print stuff, at least I don't think it does. But it's a way that you can encode more information in places. So you'll see a few of these throughout this lab. And if you ever want to add your own, if you do control and then click, or what I guess it's like a left click or maybe a right click, I don't know if you're on a PC instead of a Mac, it should give you the option to add a new note. When you add a note, it puts up this new flag and lets you type in whatever you want. That's not anything you ever need to do, but just an FYI. I don't want this note here, so what I'm going to do is control and then click on this cell again and then delete the note. Now it's gone. Anyways, back to the lab. You got 4 different tabs. The first one are just some instructions. You can read through those. I tried to color coordinate things to kind of correspond with the different tabs where you'll be doing your work. This first tab in red, there's nothing for you to do. All it says is the stuff that you've been doing in our class with the normal CDF and the inverse norm function. You can do that in Excel as well. So this talks a little bit about the normal CDF function. This is the Excel version of the normal CDF function. It's called normDist. And this talks a little bit about the inverse norm function. And this is the Excel version of that called norminv. And in here, it tells you what the arguments need to be when you're using Excel. They're a little bit different than the TI arguments, but they're pretty similar. You'll see a lot of similarities between the two. So the idea on this lab is to kind of do the same thing that you've been doing with normal CDF and inverse norm, except do it in Excel. So you'll get some practice with that on this green tab here. So the idea is I tell you that cars' age are normally distributed. I give you a mean and a standard deviation, and then ask you a bunch of questions. These questions should feel a lot like homework questions dealing with normal CDF and inverse norm. So what I'd recommend you do is first answer all these questions using your calculator, right? Use normal CDF and inverse norm and get your answers and type them in here. So maybe your calculator tells you that, I don't know, 32% of cars are less than 10 years old. Then you type in 32% here, which you can type in as 32 and then the percentage sign if you want, and it'll store it as 32%. Or you can type it in as 0.32, and now it's stored as a decimal, 0.32. But if you'd prefer it be stored as a percentage, you can just change the formatting. So you might have a shortcut for changing the formatting up here. The cell's highlighted, I click on this little percentage sign, and now it's saved as a percentage. If I wanted it as a percentage rounded to 2 decimal places, for example, I can increase the number of decimals I have here by clicking. Now it's 32.0, 32.00. I don't care too much about the formatting, but it's really easy for you to change the formatting. And I guess there are instructions telling you how you should do the formatting in here. So again, you can either put in the percentage sign and then Excel automatically knows you want it formatted as a percentage, or type it in as a decimal and then change the formatting into a percentage here. Once you have all your answers in orange, see if you can recreate those answers in green using the Excel functions. Right, so this answer isn't 32%, but pretend it was 32%. Then maybe you'd come over here and you try using normDist. And if you understand the arguments, maybe you'd put in something like 10 and then 8.3 and then 2.4 and then another comma, and you always put in true here. You don't have to worry about that too much. You'll never use false. We'll always want the cumulative distribution function. It's kind of like telling your calculator that you want normal CDF instead of normal PDF. Anyways, you type all that in and you get this answer here. You're like, uh-oh, my answers don't match up. I must have done something wrong. So either double check your Excel work or double check your calculator work until things line up. You'll note that Excel formats things as a decimal, not as a percentage. But again, that's not a big deal. Just click on the cell and come up here to percent, or go up to format and then cells, and you can change it into a percentage here. Where is it? Percentage, somewhere down here. This even lets you choose how many decimal places you want. That's kind of cool. Now it's outputted as 76.06. Note that these aren't all percentages. Sometimes they want to know the age of the car. Sometimes they want to know a probability or a proportion. I thought the second and the third questions here were kind of tricky. So I put in little comments in here to try to give you hints on how to figure them out with Excel. They're both fairly straightforward with your calculator, so you should be able to get the right answers here and here. But with Excel, because normDist, you don't give it a lower bound and an upper bound, you kind of just give it an upper bound. You got to be a little bit clever to figure out the second and the third question. And again, there's some hints in there for you. So work through all of these. Hopefully all of your Excel answers will match all of your TI answers. Change the formatting as indicated down here, and then you can move on to the last tab, the Dragging Formulas tab. The idea with the dragging formulas tab is one of the big advantages to Excel is you can do lots of calculations really quick. And in order to do lots of calculations really quick, you'll be dragging formulas. What do I mean by dragging formulas? If you click on this cell, what is it, C5, I guess, you can see that there's a formula in there, B5 plus C4. Right, if I click up on the formula bar, it'll tell me, it'll highlight the red and the blue cell. I can see that these two numbers are being added together. 1 plus 1, the answer equals 2. But I can drag this formula. If I click on the cell, it's highlighted. In the bottom right, there's a little green box. If I hover over that green box, I can drag the formula down. What that does is it fills in all these cells with a similar version of the formula. I can now grab that same box in the bottom right and drag that all the way to the right. And now it's filled in all of the boxes with the formula. As you can see, the numbers are different in these different purple boxes. And that's because when you drag the formula changes. And to give you an idea of how it changes, just click on any cell you want. Maybe this one right here, this 42. How is Excel coming up with the 42 here? If I click on the formula, I can see that what it's doing is it's adding up the cell in blue and the cell in red, F6 and G5. It's adding up this 16 and this 26. 16 plus 26 gives me 42. Why is it adding up those numbers? Because those numbers are directly above and to the left of the cell that I'm talking about. Right? Our formula started here by taking the cell directly above it and directly to the left of it and adding those up. And when I drag the formula down, the cells that it references changes. Cell right above, cell right to the left. When I drag the formula down, the cells that were being referenced all drag down as well. And when I drag the formula to the right, the cells that were being referenced all drag to the right as well. Sometimes that's what you want. Sometimes you want the formulas to kind of move with you, and sometimes you don't. And the idea for this tab is to figure out how to tell Excel that you want the reference cells to move, or you don't want them to move, or you want them to move somewhat but not completely. And the way you do that is with dollar signs. And you're probably like, what are you talking about, dollar signs? Well, what I'm asking you to do here is take all of these formulas and drag them down and drag them to the right. So if you look at this cell, you might think the formula is identical, right? It's the cell above it and the cell to the left that are being added up in red and blue here. But you'll note that now I have some dollar signs here. If you look at this formula, it was just B5 plus C4, the cell above it, the cell to the left of it. I think I said to the right a minute ago, but it's to the left. But anyways, the point is there's no dollar signs. If you look at this formula, it's almost the same. It's the cell to the left of it and the cell above it. But now you have these dollar signs. And look what happens when I drag the formula. If I drag it down and drag it to the right, now the answers look different than they did up here. Why are they different? They're all 2s here. Why are they all 2? Well, click on a cell and see what happened. Oh, it's still this cell and this cell. When I drag the formula left and when I drag the formula down, it didn't change the cells that were being referenced. Remember up here when we dragged it left and dragged it down, the cells that were being referenced moved with it. Here they don't move at all. Do that same thing down here and take a look at what happens. In this version, my formula had some dollar signs, but not all of the dollar signs. I had one in front of the letter on the blue cell and also the letter on the red cell. And when I dragged the formulas down and to the right, what ended up happening? They moved down, but they didn't move to the right. That's interesting. Now look at this formula. Looks like I have dollar signs on the numbers, but not the letters. I wonder what will end up happening when I drag the formula down and then drag it to the right. Let's click on a cell and get an idea. Oh, it looks like now they're moving left and right, but they're not moving up and down. Here's one where I have a dollar sign on the letter and the number for the blue cell, but only the number for the red cell. If you're starting to get an idea of what the dollar signs do by looking at all these different results, maybe you can predict what will happen when I drag this formula down and drag this formula to the right. Some stuff changes, some stuff doesn't change. Maybe by looking at all of these formulas in purple and comparing where the dollar sign was in each instance, you can briefly explain the significance of the dollar symbol. What does it do in Excel? And once you figure that out, maybe what you can do is write a formula here that you will then drag to fill up this entire kind of pink box here, so that any cell in here, like this one, for example, will add up this 4 and this 3. Right? So I don't want to add up the number directly above it and directly to the left of it. I want these ones to kind of move left and right and these ones to kind of move up and down. And if you write the formula just right and you drag it all down, what you'll end up seeing are the numbers that you see down here. So the idea is you kind of learn what the dollar signs do up here. You explain in words what the dollar signs do, and then you prove that you understand what the dollar signs do by writing your own formula that adds up this number and this number, but with some dollar signs in here so that when you drag the formula, You don't get the numbers that you see in purple in front of you. You instead get these numbers in purple down here. Finally, the last thing to do on this lab is to calculate a bunch of percentiles. Wait, percentiles? I think I've done that before. Yeah, you determined the 99th percentile for car age already. You learned how to do that in this part right here. You're going to redo almost the exact same formula you have right here, except this only gives you the 99th percentile when the mean is 8.3 and the standard deviation is 2.4. What you want is a formula so that the percentile will change. You'll get the first percentile, second, third, fourth. When you drag this formula down, you want the percentile to change. And you want the mean to stay the exact same, but you want the standard deviation to change. So for example, the number that you see right here will end up being the 16th percentile when the mean is 50 and the standard deviation is 14. So build your formula that will look almost identical to the formula that you have in this cell right here, B12, except instead of typing in 0.16 for the area for this percentile, make the area equal to 16 divided by 100 to make it 0.16. But you don't want the whole answer to be 0.16, right? That's just one argument in the norm inverse function, right? Norm inverse, you first want the area. Make sure the area is a decimal, so not 16, but 0.16. But don't type in 0.16, because if you type in 0.16, then when we drag the formula down, it'll still be the 16th percentile when we're down here, for example. The mean we always want to be equal to 50, so I guess you could just type in 50, but really what I had in mind is reference this cell, but maybe think about how you can put in dollar signs so that when we drag the formula, it still references this cell. That doesn't move at all. And then for the standard deviation, I guess you'd want to reference this cell if you were figuring out this box. And we want the standard deviation to change left and right as we drag this formula left and right, but we don't want it to change up and down. So think about where the dollar signs are going to go. And I just picked a cell arbitrarily here, right? The 16th percentile. But really, when you're building your formula, what you'll do is you'll type the formula up here. So write a formula in this purple box that tells you the first percentile when the mean is 50 and the standard deviation is 8. And then, this is probably the hardest part, put your dollar signs in very carefully so that when you drag the formula down and drag the formula to the right, the formula does exactly what you want it to do for every cell in this pink area. To make sure that's working, check a couple of them, right? Just spot check something. Pick one at random. Pick this one and make sure that it's really telling you the 30th percentile when the mean is 50 and the standard deviation is 14. You might have noticed that there's hints in this and in here, essentially just typing out what I've said in this video, hopefully. I planned on making this video super short. It's already gotten kind of long, but hopefully that's helpful for anybody who is struggling with this lab.